Welcome students. In our last lecture, we had solved the first order first degree equation by the method of separation of variables. Here we are considering another type of equation, that is dy dx equal to f of ax plus by plus c, in which we cannot solve directly by the method of separations of variables, but we can use a transformation by which we convert this original equation into a different equation and then apply the separations of variable method to get our final solution. Now how we do it? The procedure is that, okay, suppose our dy dx equal to function of ax plus by plus c, then we are assuming a transformations like ax plus by plus c equal to b. Okay, and if we differentiate with respect to x, what we get? A plus b dy dx equal to dv dx. Okay, right? Suppose consider this equation, solve dy dx equal to 4x plus y plus 1 whole square. So we are assuming 4x plus y plus 1 equal to b. Now if we differentiating 1 with respect to x, what we get? 4 plus dy dx equal to dv dx. Okay, so dy dx equal to dv dx minus 4, right? Now the left hand side will be what? In place of dy dx we can write dv dx minus 4, and in the right hand side this will be, whole terms will be b square now. So dv dx equal to 4 plus b square. Now in the left hand side the variables are separated. Now what we can write? Dx equal to dv by 4 plus b square. Now if we take integration on both sides, then integration of dx is x plus add a constant c dash, and here it is integration of dx by x square plus s square. So 1 by a tan inverse x by a. So 1 by 2 tan inverse v by 2. Okay, so what we get? You just put the value of v. So value of v is 4x plus y plus 1. So what you get? 4x plus y plus 1 equal to 2 tan inverse 2 tan of twice x plus c. Now do the next problem. Dy dx equal to 4x plus y plus 1 whole square, and if there is a value y0 equal to 1, so at the point 0 y value is 1. Now as previous problem, we get this value 4x plus y plus 1 equal to 2 tan of twice x plus c. Now you put x equal to 0 and y equal to 1, okay, in the above. So what we get? C equal to 1. Okay, so so we get 10 c equal to 1. So what we get? C equal to pi by 4. Okay, so we are replacing c by pi by 4. So this is a particular solution, okay, for a particular value x equal to 0, y equal to 1. And this is the general solution because here c is present. Understood? When c is present, we call the solution as general solution. Then for a particular value of x, y, when we get the solution, that is called particular solution, right? Now similarly here you see x plus y whole square. So x plus y, if you want to separate the variables, can we do this? See, x plus y whole square is what? X square plus twice xy plus y square. So here xy term is there, na? So for that xy term we cannot separate the variables, right? So we have to use the transformation. What transformation? We choose x plus y equal to v. So differentiating both sides with respect to x, what we get? 1 plus dy dx equal to dv dx. Now our dy dx is converted to dv dx minus 1, and put this in the equation 1. Okay, so what we get? V square dv dx minus 1 equal to s square. Now you see dx equal to v square by v square plus s square dv. Okay, now you know from your class 12 integration process, if you add plus s square minus s square, this will be 1 minus s square by v square plus s square. S square is constant. Now if you take integration both sides, what will be in the left hand side? X plus c, and then in the right hand side integration of dv is v minus s square into 1 by a tan inverse v by a. Okay, So here this is your general solution. Understood? Similarly, another problem, sec of x plus y here is given. So you just put x plus y equal to b. So dy dx equal to dv dx minus 1. You get what? dv dx minus 1 equal to sec b. Okay. Now you solve this integration. You get x plus c equal to b minus 10 half of b. Ultimately, you have to again put the value of b here. Okay. You get your final solution. Understood? Okay. So by this way you have to solve some other problems, right? Now see, here the transformation is that what you need to do, you first make dy dx. Okay, so this is homogeneous equation. So when we have the homogeneous equation, what we need to do, we have to form a function of y by x. What we need to do, we have to form a function of homogeneous y by x. What do we mean by homogeneous equation? All the powers are same. Here x power is 3 and in total the power is 3. Here y power is 3, in total the power is 3. Okay, so if we divide it by x cube, then this will be 1 plus 3 of y by x whole square, because already x is there, and here is y by x whole cube plus 3 into y by x. Okay, so if you put y by x equal to b, then that is y equal to bx. So dy dx equal to what? This will be ub method, na? So b plus x into dv dx. So dy dx is what? B plus x into dv dx. Okay, so in place of dy dx, what we can put? B plus x into dv dx. Okay, and in the right hand side will be minus 1 plus 3b square by v cube plus 3b. Okay, next you take v in the right hand side. So what we get? X dv dx equal to minus 1 plus 3b square by b cube plus 3b minus b. After calculation you get this. Now you can separate the variables. Okay, so what you get? Ultimately 4 into dx by x. Okay, 4 into dx by x, and right hand side this value. Now we have to solve this. Okay, so you know that in this left hand side is log x, right? And if you take this t, its derivative is in the numerator. Okay, so this is like minus log this plus log c. So you get the value, right? So you just do like this way. So these are the homogeneous equations. Dy dx equal to this, c power is x, power is 1, power is 1, and here although power is 2, there is 1 by 2, so power is 1. Okay, so this is like the you have to convert the equation into function of y by x. Okay, so if you can write like this, y by x plus 1, because if you take inside if you want to take this x inside this root under, then you have to square it, no? In the inside root x. So this will be 1 x square root under x square plus y square by x square. So 1 plus y by x whole square whole to the power half. Now if you take y by x equal to b, that is y equal to bx. So that dy dx equal to what? B plus x into dv dx. Okay, so left hand side will be b plus x into dv dx, and right hand side will be b plus root under 1 plus b square. Okay, so dx by x equal to dv by root under 1 plus b square. Now you take the integration both side, log x plus log c equal to log of, you know the formula, log of b plus this. After this you get the final value, and you get in terms of b, and you have to put b as y by x, and then you have to write your final answer. In exam, you just, if you do up to this, you will not get the full marks. Okay, for getting the full marks you need to again transform this value of b as y by x. Okay, so this is already in the form of y by x, so you have to transform y by x equal to b. Okay, then do the same things. So here are so many problems that are already solved. So what you need to do is that you need to practice all these things. Okay, so after solving all these examples, then you come to this exercise. Okay, so for in this lecture, your exercise is exercise 2b and 2c. So do all these problems. Okay, if you have any doubt you can ask me. Thank you.